What's up, guys? It's Rec again. And today we have a brand new update for the Haystack Dependency Injection Framework. I'm adding a visual graph editor feature. And in this video, I'll show you how it works and why it can improve your workflow inside Unity. All right, here's the demo scene for today's video. This scene uses free assets from the Unity Asset Store, which I'm using to demonstrate the system. Before we begin, let me give you a quick overview of this feature. This new update introduces a visual graph editor for dependency injection that helps developers build systems faster, organize dependencies more clearly, and create cleaner project structures. The visual editor works similarly to other node-based tools such as Unity Shader Graph, Behavior Tree Editors, Playmaker Visual Scripting, or even Blender's Shader Editor. If you're already familiar with node workflows, you'll feel right at home. All right, let's proceed. Let's run the game first and see what's happening. As you can see, there's nothing visually special happening in the gameplay itself because this demo focuses on dependency injection behind the scenes. So now, let's inspect how the scene is actually set up. We have the default game objects from the asset pack I'm using, along with the character, the door, and most importantly, the Hey Graph Runner. So how does it work? Let's open the graph asset and inspect what's happening inside the graph editor. As you can see, we have a lot of nodes connected together. Don't worry, we're going to explore them one by one. Let's start with the Haystack Graph menu bar. As you can see, we have File, View, Graph, and Debug. Inside the File menu, we have Save and Load. Inside View, we have Center View and Minimap. Inside Graph, we have Add Node and Autosave. And inside Debug, we have Validate, Validator, and Templates. Now, let me explain each one briefly. The Save and Load options are used to save or load graph assets in your project. The Center View button automatically moves the camera to the center of all nodes in the graph, making navigation easier. The Minimap gives you an overview of the entire graph, which is very useful for large setups. The Add Node option allows you to create new nodes. As you can see, there are many different node types available depending on what kind of setup you want to build. Auto Save automatically saves the graph whenever changes are made, so you don't accidentally lose your progress. The Validate button checks the graph for missing references, invalid connections, or setup errors. The Validator panel displays the overall validation status, including the total number of nodes, warnings, and errors. Finally, templates provide pre-made graph setups that help you create common dependency injection structures much faster. Now, this particular graph sample is a bit complicated for a first explanation, so instead, let's switch to a simpler example. Let's open the Graph Service Relay sample scene, then go to the Hey Graph Runner and click Edit Graph. All right, now we can see a much simpler setup. We currently have three main nodes: Installer Node, Bind Instance Node, Inject Target Node. The Installer node is responsible for starting and installing the dependency setup. You can think of it as the entry point of the injection process. Next, the Bind Instance node contains a reference to the service game object that we want to register into the dependency container. Let's open the service script. As you can see, the script only contains two declared variables and nothing particularly special. However, this object becomes accessible through dependency injection because it is registered by the Bind Instance node. Now let's check the Inject Target script. Here, we have a reference to the service class with the Inject attribute attached to it. This Inject attribute tells Haystack to automatically inject the dependency provided by the graph node system. So instead of manually finding references using getComponent, findObjectOfType, or singleton patterns, Haystack automatically handles the dependency assignment through the graph setup. This makes your project cleaner, easier to maintain, and much more scalable for larger systems. There are also a lot of graph asset examples included that you can explore and study. As you can see, we have examples for Async Service Inject, Conditional Bind, Decorator Bind, Event Signal, Factory Pool Inject, and use the setups that best fit your project architecture. The goal of this visual graph system is to make dependency injection easier to understand, especially for developers who are more comfortable with visual workflows rather than writing everything manually in code. It's especially useful for team projects where readability and scalability are important. Compared to the traditional approach using singletons, findObjectOfType, or getComponent everywhere, Haystack helps you create cleaner and more modular code. Your systems become less dependent on direct references, making them easier to expand, test, and maintain in the long run. This asset is still actively maintained and will continue receiving updates for better performance, fewer bugs, more features, and improved reliability as an enterprise-level development tool. Alright, that's it for today's video. I hope this visual graph update helps make dependency injection easier and more enjoyable for your Unity projects. You can use Haystack as your development partner to build cleaner, faster, and more scalable games. Have a nice day, and I'll see you in the next video.